For the first question, 1A, it asks to show the particle interactions of xenon atoms in their solid state. And this is the liquid state that it gives us, and here's the solid state. So the particles are more compact in their solid state and in a tight structure, a lattice-like structure. And then for B, for 1, it asks to show in the gas state. So the particles are going to fill up all the space that they have in their volume area. So unlike liquid, it's going to fill up all of it and expand as much as possible. For question 2, it says let P and V represent the pressure and volume of the xenon gas in the container in diagram 3. If a piston is used to reduce the volume of gas to V/2 at a constant temperature, what is the new pressure in the container in terms of the original pressure, P? So if you put V/2, that means you're reducing it in half, dividing by 2, and we know that pressure and volume are inversely proportional. So when you half one, you double the other. So when you half the volume, you double P. So this is inversely proportional. You half volume, you double P. Here's the PV/nRT equation with P on just moved over to one side. When you divide by V by 2, you multiply P by 2 because they're inversely proportional.
Question 3 says, describe what happens to the average speed of the xenon atoms in the container in diagram 3 as well as the original volume. As the original volume V is reduced to V2 at a constant temperature. If the volume was decreased by 2, the speed of the xenon atoms would increase by 2 because Boyle's law says that pressure is inversely proportional to volume. P1V1 equals P2V2. So if you divide the volume by 2, the pressure is doubling by 2, which means that the particles are moving at double the speed, because whenever pressure is increased, particles move faster with more collisions and more bouncing off each other. So the overall speed will always increase with an increase in pressure.